Let us look at this example on how to calculate the force from a system. So um, this problem, well, in this problem we get a force which they have given us the components. It's negative 40, 20, and 10k, meaning that in x, which notice that x here is going to be this axis, y is horizontal, and z is vertical. So they can be careful because they can give you the axis in different configurations. As long as x and y are orthogonal and y is orthogonal with respect to x, this is an acceptable configuration. All right, so they're telling us that the force is located at negative 40x, which is true. Negative 40 is towards the back of the page. Positive 20j, that is true, is at 20 positive, which is towards the right hand side of the axis. And 10k, that is true, is located towards the vertical upper direction. If we wanted to calculate the magnitude, which we don't need to at this point, but if we wanted to calculate the magnitude of the force is equal to the square root of negative 40 squared, we know this by now, 20 squared plus 10 squared. That, actually we can do it right now. Just to have an idea of what's the magnitude of the force. Okay, so that is negative 40 squared, or perhaps I can even use Wolfram alpha for this, so you guys get familiar on how to use Wolfram alpha. Okay, so we're gonna do square root of, let's go close parentheses first, the first term squared plus second squared and the third term squared, and now let's populate this guy. It's negative 40, positive 20, and positive 10. So that force has a magnitude of 48.8, let's say 46 newtons. And that force could be because, let's assume there's water going through this pipe and it's a high pressure, then that water or that liquid is causing this force to go up because of the, I don't know, turbulence or some extra pressure. All right, so this is how we calculate the magnitude. We know this by now. However, the problem is asking us to to determine the moment about the axis x and the axis a. So we need to determine the moment with respect to the axis x, which is positive x, and the moment around the axis a, which is the concentric axis going through the pipe. All right, so for that, we have to do two operations. We have to do the moment around the axis a, or sorry, let's do x first. The moment around the axis x is going to be basically the distance from the force to the axis, that is given by RA. Let's write this down the right way. This is equal to RA cross F, okay, F the vector, but the condition is that this has to be dot I. Okay, and I is very simple. I is the vector that goes through 1, 0, 0. Okay. Yeah, we've talked about this before. I is 1, 0, 0. J is, if they ask about j, that's 0, 1, 0, and they ask about z or k, k would be 0, 0, 1. So it's very simple if they ask you about the x's, because it's 1, 0, 0, 0, 1, 0 for j, and 0, 0, 0 for 1 for k, which is x, y, and z. So it's very simple. For a, we'll have to find that in a minute, but it's basically given by these distances, and we have to find. So has 0 components in k, but has a component in x and another y, another component in y. All right, so let's go ahead and try to solve for the moment around x. First thing we have to do is locate the force. That's always the first step. So RA is equal to the distance from A to O, or basically let's find the vector O, which is origin to the point A. So remember, the head of the vector minus the tail of the vector. So we usually do this right here. So A is located at, so let's go ahead and see 3, but negative. How many units in y is 4, positive. How many units in z? 6 meters. Okay, so if you notice, this point with respect to x is located at 4, negative. Sorry, I'm looking at the wrong one. Is located at, this is the distance at x, right here. Negative 3, y is positive 4, and z is positive 6. Okay, therefore, the distance for vector A is equal to A minus O. What is A? It's negative 3 minus 0, which is negative 3, is 4 minus 0, and is 6 minus 0. Okay, that is our vector A. Now, what we have to do next is this operation. And if you notice, it's basically doing moment in x, we can rewrite it as I dot the distance from the force to the origin cross the force. All right, next point would be to set up the equation. So mx, the moment around the axis x, is equal to, so we have a cross product here. So the F, the force, is negative 40, 20, and 10. The distance is negative 3, it's right here, positive 4, and positive 6. So this line corresponds to F, this line corresponds to A, and the first line corresponds to I. And what is I? Is 1, 0, 0. So we basically have to do the cross product or the curl of this operation. Okay, so don't get confused with this is just telling you where each line goes. So just to remind you, this I is this axis. In the case of A, we'll have to put A up here. So I dot R cross F is I dot R is this line cross F. This is how you set it up. And the solution for this, we already know how to do. This operation is going to be 1 times cross, so cancel this line, cancel this line, and cancel that line. And then it's 4 times 10, which is 40, minus 20 times 6, which is 120. Minus, well, everything else is 0. So 0 times whatever it is. But actually just practice, use this opportunity to practice how we would do this. Let's do the second one. So here we had 1, we have negative 40, and negative 3, j and k. All right, so for j, which is 0, what we do is cancel this column and cancel the j column. Whoops. The first column, because the cross product is between these two vectors. So you always cross the first row, but you cancel the columns of the I, j, and k. So this is 0 times negative 3 times 10, which is negative 30, minus, it's always minus, 6 and negative 40. So positive 6 times negative 40 is 6 times 4 is negative 240. 6 times 4 is 24. All right. And for the third, operation around k, 1, 0, 0. In this case it's easy because it's 0, so plus 0. Let's get rid of this line too. 4 and 20. Okay, then we cancel this column, and again the first row, because that's just the dot product. Always cancel the first row. And for k, we have 0 in k, and then we have negative 3 times 20, which is negative 60, minus negative 40 times 4, which is negative 80. Okay, but this is 0, so it's good news. We only have to calculate 1, which is the first term. So the moment around x, so actually this would be the total moment. The total moment is that, but the moment around x is just the component for I, and that is 1 times 40 minus 120, and this is equal to negative 80, and the units are, this is unitless, this is in meters, and this is in newtons. So each multiplication is newtons per meter, which is the units for the momentum. Or for the moment, not the momentum, I'm sorry, the moment. Momentum is a completely different concept. All right, so we have the first answer. which is what is the moment of this force around x. To find the moment around the axis A, we will have to find lambda A. Okay, let's actually move down here. Okay, so if you notice this is what we're doing. The force is applying a moment, and they're asking us to find it across or with respect to the axis x and with respect to the axis A. So how do you know if it's positive or negative? You just start pulling each component of the force. So this has a component that way, which in this case is y, up, which in this case is z, and like so, which in this case is x. So in x is not going to have any particular moment because it's pulling across the same axis. But notice that in y and in z, it will have something, and that's actually what we found out here. It's going to have for x contributions for y and k, and the answer is negative 80. So it's just rotating clockwise around x. So the answer is telling us the rotation. All right, so we knew these axes. The alpha for this, or the lambda for this, was 1, 0, 0, which is up here. What we need to do now is find the lambda for A. So let's go ahead and do that portion, which is the second question. Okay, so moment around A. Okay. So we have to find what is A. So lambda A is equal to the vector RA lowercase, because A uppercase is this point, A lowercase is the axis, and the magnitude of R A lowercase. So first of all, what is the direction of A lowercase? We have to go up to this picture again. So we can use, they're giving us this point right here, but the angle is the same if you use these points or other points right here. They are the same angle. So as long as we know the angle, we can use that for the coordinates. Or basically, we just use this distance. So don't get confused. If it's an axis, it will be the same position. It will be the same unit vector if we could compute it from here, or if we compute it from this point here. But let's use the dimensions right here. What I'm saying is that A lowercase has dimensions x, y, and z, and those dimensions are in x is, well, it's the same as the capital A actually, is -3, and in y is the same as capital A, which is 4, but in z is 0. All right, so if we want to compute the magnitude of, well, first of all, before we do the magnitude, we have to do RA, the distance from origin to A. It's going to be the head minus the tail. So the head is at A, so it's -3 minus 0 in I. It's 4 minus 0 in J, and it's 0 in K. 0 minus 0 in K. So the magnitude of A, or R, A lowercase, is equal to square root of negative 3 squared plus 4 squared. And this is equal to square root of 9 plus 16 is 25. And this is equal to 5. Okay, so we use this to find our lambda. So lambda, which is the unit vector of the axis, the same way that axis x has unit vector 1, 0, 0, axis A, which is an arbitrary axis, has a unit vector of, and we're going to find that right now, r divided by magnitude of the, so basically computing this guy. And that is I, j, k. And we know that k is 0 because it's going to be 0 divided by 5. All right, but what is I and j? I is negative 3 divided by 5, and j is positive 4 divided by 5. So very simple. What we have to do is the moment around A is going to be lambda A dot R A lowercase cross F. Okay, the components of F. And this is equal to, so remember we have lambda A R A F. So lambda A is negative 3 over 5 and 4 over 5, 0. Our A is negative 3, 4, 0, and F is negative, what is it? I forget. Negative 40, 20, and 10. And what is, oh, wait a second. This is actually RA, capital A. Yes, I apologize. Remember that is the same thing as before, but the only thing that it changes is the axis that we want to compute against. So in this case, it's RA, and this is not 0. RA was 6 and K. All right, so let's do this one more time. So this is going to be, and first of all, it's going to be negative 3 over 5. That multiplies. So we cancel this one and this one, and it's going to multiply 4 times 10, which is 40, minus 6 times 10, which is negative, which is 120. All right, minus. Then we do this and that. So it's going to be 4 divided by 5. And 4 divided by 5, which is this guy. And then we do, I can get rid of this guy. Minus 3 divided by 5, minus 3, minus 40. So for this second element. We have 4 divided by 5, and then negative 3 times 10, negative 30, minus negative 40 times 6, which is negative 240. So minus and minus is, well, let's do this first. 6 and 40 is 240. And then plus the third element, which is 0. 0, and for 0 you would cancel. I don't know if this is going to be too difficult to see, but let's try it. For 0 you will cancel this one and that one, and it will be 0 times negative 3 times 20 is negative 60, minus negative 40 times 4 is negative 80. Okay, so around A, the moment around axis A is equal to negative 3 over 5 times negative 80 minus 4 divided by 5 times this 2 is positive 240, and negative 30 is negative 2 positive 210, right? Because this is positive, minus 30 is positive 210, plus 0. Okay, so we simply have to compute this now. Negative 30 and negative 80 is plus or positive. 3 times 8 is 24. 240 divided by 5. And this is negative 4 divided by, let's use the calculator for this one. So 210 times 4 divided by 5. 4 divided by 5 times 210 is 168. Negative 168. And negative 3 over 5, 3 times 80 divided by 5. Is 48. Okay, so we're gonna have a negative number here. So this is 8 and 8 is 160. So this is equal to negative 120. And the units are Newton per meter. Okay, so the moment around A, the axis A, is negative 120 newtons per meter. So it's basically going to be clockwise as well. It's going to be clockwise. I think there's a typo here. There should be clockwise. Clockwise 120 newtons per meter. Oh, no, this is correct. This is correct. This is correct because that is correct because okay, so the way we know the direction is using the right hand rule. So if you try and grab the axis with your fingers and you extend your thumb, the thumb will show you the positive side of the axis. So like in this case, y is positive. Yeah. If you try and the palm, the axis should be covered by your palm underneath. You know what I mean? So like in X, you grab the axis underneath, wrap your fingers around, and the thumb will show you the positive direction. And Z is the same thing. So you try to grab it, and your thumb will show the positive direction. Okay, the same thing here. If you try and grab the axis such that your thumb is showing the positive direction. The thumb is going to be like that. The moment your fingers will wrap around this way. That is basically the positive direction. So since you got a negative, the negative is going to be the opposite, right? So positive would be wrapping your fingers around it. This is positive. Well, negative would be the other way. So negative is going around like so. All right. So, but you got the answer right here, which is the important part. So the question was, what was the moment around X? We found it. It was very simple. It was just doing the distance from the origin to the point where the force is applied, cross the force, and then dot product I. And the dot product is just the first equation right here, the first expression right here. And to compute around an arbitrary axis, you just find the directions of the axis. And that axis A was pretty simple. And you do the same thing. Place the A axis, the components of the unit vector, the first row, and the second and third row are going to be the direction, the distance from the origin to the point of the force cross the force. All right. So if later on they ask you for another force right here, you know, they give you the components in I, J, and K, it will be the same thing. You find, and this is point B, for instance, you find the distance from O to B, RB, and this is force 2. So it's basically force 2 cross, or sorry, is B, RB cross F2. This right here will be RB, the direction, the distance from origin to the point B cross F2. All right, that's the moment around O. That is moment around O. The point O. If you want, and this is going to be a vector, if you want the moment around an axis, it's going to be a number. And that is going to be the moment around, say, axis A is going to be the unit vector of the axis, which we know how to do, times RB cross force